Hey, it is 2 hours UTC, and it is time again for Astronomy Daily Live. Hey, everybody, you can call me Cosmic, and welcome back to the Circle of Friends. My hugest apologies for having to cancel yesterday. It was just a shitty day, and it just ended up in the crapper. So that's how those kinds of things go from time to time. But I'm feeling better. Um, yeah. It's just one of those things that one has to deal with from time to time in this life. So yeah, I don't let it bother me too much. Just sort of move on, enjoy as much as you possibly can, and that's it. That's it. So yeah, hope everybody's doing well. Let's talk some astronomy for a little while. Let's get back into the groove. I've been starved. I've been starved for a whole day, not talking astronomy. It's just ah, end of the world, end of the world stuff. Yeah, uh, hope everybody's doing well. Um, don't have anything really off the top of my head in terms of astronomical stuff. Any events that happened in the past 24 hours or so. Um, just your basic awesome stuff. So I've got the uh, I've got the hydrogen hydroxide tonight, HOH tonight. So cheers. There were a couple of people uh, from another YouTube channel. In this case, uh, it was one of Gilles' channels, and I had gotten on there, and I try to not, I mean, when I go on, to somebody else's live stream, I am not there to promote my own stuff. I'm there to support and to talk with um, the host, the host. So, but if that host um, mentions me and or my channel, or if somebody in the chat does, then I think it's only fair and right, to sort of provide a little bit of information. But even that, I keep it to a minimum because their live stream is not my live stream. This is mine, and I can do and promote anything I want here. And yeah. I guess I sort of expect the same treatment. Um, I don't know if I'll um, ever get that kind, but what I like to do and what I haven't done in quite a while is do some shout outs to some different um, um, YouTube channels that I've watched for years, like the people, all of that, um, and so yeah, the first one is Gilles' um, live streams. Has nothing to do with astronomy at all. He does. He says he's got 5 different channels, and I'm only aware of 4 of them. So I'm missing one. But he's got a um, a VHF UHF radio channel. He has a shortwave radio channel. He has I guess it's called a Windows Insider channel, and then he's got another sort of general computer kind of like a Q&A type of a channel, and apparently he has another one as well. So big shout out to him. He's doing this full time, and yeah, he does three or 4 hour shows, um, each one occurring once a week. So hey, I'm going to, before I forget, lest I forget, I'm going to tweet that I am live now, and I'm going to get onto my smartphone here and pull up this live show so I can sort of monitor it. Whoop, monitor the live stream, just just in case anything funny goes awry. I want to see it too. So, all right, cool. All right, we are up and running. So, this is just a fun, casual get together of friends. I sort of see it as you know we all sort of stroll out to our virtual porch outside. It's got the awning and um, uh, comfortable chairs, and we have our beverage or other consumable of choice, and we're just sitting around chit chatting, looking up at the darkening sky, and talking astronomy. And it's nice to have a daily thing because we can sort of keep on top of the latest news, which is always fun because I get to scoop all the other podcasts that way, a little tiny bit. Um, but yeah, it just it keeps us all informed and updated as to what the latest and greatest stuff is. Um, you know what? Something that I should mention, and I haven't yet, is I think there's a meteor shower going on, and I'm going to. Is it the Lyrids? I've been hearing all about this and promptly ignoring it. So I'm going to do a quick Google here. You can watch me. You can watch me stare at the screen. Is it the Lyrids? Lyrids meteor shower 2018. Uh, let's see. Okay, so will be the best day to see the Lyrid. Here, let me share my screen here. Dun, 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 dun. Go to infinity. And then pull this up. Uh, space.com is a pretty good site for that. Late April, skywatchers in the northern hemisphere will get to view the Lyrid meteor shower associated with comet. Blah 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 blah. So the best day to see the Lyrid meteors will be extremely early on the morning of Sunday, April 22nd. So I, is that? I guess that's UT time. Um, so very cool. Go out. It's best, as it sort of implies here. It's best to well, you've got your best chance of seeing a meteor from a particular shower, um, usually after midnight, and that's because primarily where you're located on the Earth, you're starting to spin into it, right? Spin into it a little bit. And usually what that means is that the radiant, the point at which all the meteors seem to be coming from, is rising. So, of course, this is called the Lyrids, which is coming from the constellation of Lyra, which rises pretty close to around midnight or so. So check those out for sure. You can definitely see them earlier um, and later. And I always, I never remember which site it is, but there is a site that monitors the um, uh, rate, right? How many meteors per hour uh, is sort of being seen. And there's a site that does that, and I always forget what it is. So anyway, check out the Lyrids. Not too many, um, 18 per hour. So you're talking what, about one every 4 minutes, one every 3 minutes, something like that. Let me grab my handy dandy calculator here. 60 minutes divided by 18. Yeah, so that's one every 3 1/3 minutes. And let me tell you, if you haven't observed meteors yet, um, it's it's like 100 times worse than watching water um, come to a boil, right? You sit there and you wait and you wait, and it seems like a million years, and then you know you get one, and but yeah, this isn't a terribly exciting one, but it's happening. So go out, take a look. Again, this is the kind of thing that doesn't require any kind of telescope at all, right? The only thing that it really requires, and it doesn't necessarily require this, but this does make it a lot easier, is one of those lounge chairs, the ones that you can lean all the way back. Um, Either that, or you know, throw a throw a sleeping bag on the ground. It's a little bit cold still, I guess, in most in most parts of the northern hemisphere, at least. But uh, you know, throw a sleeping bag on the ground and just watch. Just watch. Don't need a telescope. Don't need binoculars. Don't need anything at all. You just need some good eyes and a relatively dark sky. But you don't really even need that. You can see these things right in the middle of the city. If you're under a street light, that's probably not a good idea. But if you're even in the middle of a downtown, you'll see some brighter ones. And of course, the darker you go, the more you're going to see, because there's a lot more small ones than there are big ones. That's just how it seems to be how the universe works. So cheers to the Lyrids. All right, well, cool. I you know missing one day, as I said, it sort of uh, makes things seem to pile up a little bit. Now, why is this? I don't know why this is supposed to be my Discord server, and it's trying. I really appreciate Space TV and Uncle Bill's dialogue this afternoon or this morning. I'm not exactly sure when it happened. I had posted a question about how to get a hold of um, all my subscribers, and as soon as I read Space TV's reply, it's like, well, duh, that is the best way. I was thinking, like like some kind of a text thing, but this is YouTube. We don't do text. so so yeah, I think that's a great idea, and that's exactly what I am going to do. So tomorrow, uh, the live stream is not going to happen. I have a musical gig um, down in Bisbee, Arizona. There's a festival going on there right now. They're wanting to try to make it sort of the next Coachella, right? So okay, yay. Regardless of that, me and my musical partner are going to be down there tomorrow, tomorrow night. Um, let's see, we're starting at 0 hours 30 minutes UTC, and um, we're going to about 2 hours UTC. I think we have about an hour and a half set or so, and Danny plays native flute. Now, the funny thing on the website advertising this event, and Danny and I playing there, it does not say native flute. It says naive flute, Naive, naive flute. so so Danny's going to play his naive flute, and uh, I do all the accompaniment. So that I've got sort of the easy job. I just sort of have to drone and make little um, tinkly sounds on the keyboard. But we like that, and it's very spiritual and very uh, um, um, energetic and hopefully inspirational, right? Music is supposed to do that. It's supposed to make you feel good. And I think ours does that very, very well. So yeah, so tomorrow I will not be live streaming. Okay, that's April 22nd at 2 hours UTC. I will not be here at all. I will be playing music. So yeah, obviously that live stream is not going to happen. It sucks that I had to cancel yesterday's because it's just I hate that. Totally totally hate that. But that's how life is sometimes. Um, what I wanted to do was I wanted to um, well, let's talk about this artwork first, because this I was looking at the information I, information about the Parker Solar Probe, because I watched Tony Darnell's live stream yesterday. Caught, yeah, I don't think I caught the live stream. I caught the copy of it, um, or uh, uh, the non live stream version. Um, Caught that and thought, well, hey, let's sort of dive into what instrumentation is on, the Parker Solar Probe, as opposed to just talking about how close it's going to get and how hot it's going to get. Let's forget about all of that. Let's see what kind of science is actually going to be grabbed. And one of the instruments on there is what's called a flux gate magnetometer. And what it does is it measures the local magnetic field strength. So in 3 dimensions. So in X, Y, and Z. So somehow they've determined what the X, Y, and Z directions are, right? It's got to be relative to something, right? Relative to uh, well, yeah, I'm not exactly sure what it is. It could be relative to lots of things, obviously. But once they have that, then it's just a matter of reading the numbers and seeing what's going on, and that instrument, that fluxgate magnetometer that's going to be on the Parker Solar Probe. Well, there's also a fluxgate magnetometer on Juno, which is the spacecraft that is at Jupiter right now. And I, several months ago, created some artwork using data from that Juno's fluxgate magnetometer. And here it is. Here it is. So, and on my Discord server, I also included a description of this, but I can go through it here rather quickly or so. So these circular shapes are real shapes. That is the planetocentric position of the spacecraft. So it's as if you were standing on a particular location on sort of the surface of Jupiter. Jupiter, of course, doesn't have a surface, but some location uh, uh, on Jupiter, and you were looking at this spacecraft. Well, as the planet spins, right? One day on Jupiter is about 10 hours or so. So as the planet rotates, it's going to appear as though the spacecraft is actually rotating around you, right? So that's sort of what this is showing. And it's a little hard to tell here, but if you look at where I've marked it begin and where I've marked it end, you can see that the begin is a little bit further out from the center than the end part. And that's because this particular data is taken from a time where Juno, was relatively far out or far away from Jupiter, but moving towards Jupiter, so towards Perigove. Perigove being the closest point that it's going to go in this orbit to the planet itself. And it gets really, really close. It gets like within a few thousand kilometers, I think, just insanely close. But that's sort of the cool thing about this mission, is that they only spend actually just a few minutes, a couple hours maybe, in this very, very close proximity to Jupiter. And that's very, very smart because it's an extremely active region electrically, right? And so they can just spend a little bit of time in that area, because if they spent all their time there, the instruments would get fried. So that's what these shapes are, is sort of the planetocentric positions or position of the spacecraft. I'm going to go over to my chat to make sure that there is. Tom is here. Bobby is here. Hey. Bobby, glad you came back. Uncle Bill, of course. And yeah. No, it's not an imposter. It's just a responsible person. Yeah, responsible. So this is just basically the position of the spacecraft relative to the planet, and then these first three rings is just the magnetic field strength in the X, Y, and Z direction. So it just so happens in this data set that um, the magnetic field strength in the X direction uh, got really, really, really high, right? White is the highest, black is the lowest, right? So it got really, really high, and then it drifted down and it got really low, and then it's sort of in the middle, and then it got really high again, and then it dropped like a rock, bam, smash, like that. And then at the end, it sort of did that. Now in the Y direction, you can see it started a little high, then got really low, and got high again, and then it did this smashing up again here. Sort of a different. It's sort of a different uh, time, right? And of course, a different angle as well. And of course, um, the magnetic field strength in the Z direction is this outer ring. So, that's sort of artistic license, right? I mean, I've made these three rings uh, not radially in the same place, while of course this instrument would be, the same distance from Jupiter. So then what I did simply is I said, okay, let's make the X mag red and the Y mag green and the Z mag blue, and combine those three and make a color instead. So as you can see, when this is mostly red, we've got mostly red over here. And when it's mostly green, we've got sort of a greenish blue over here. And when it gets all, crazy and insane over here, it's crazy and insane with the colors. So yeah, so that's taking astronomical data from a spacecraft and turning it into a piece of art. And I think it's very, very cool. I've actually I have a version of this rendering that I've actually sold, and these prints uh, um, are available. You just have to ask for them. You can give me a size, and I will give you a price. So the largest I'll go is like a 24 by 24, and that's going to run you about like 75, and then it goes down from there. Probably the smallest I'll go is like a square foot or so, and that'll run probably about 30 or so, something like that. And but yeah, um, one of the people, it's pretty funny. One of the people who bought this piece, a print of this piece, um, works for the tree ring lab at the University of Arizona. So I thought that was really, really cool that a tree ring person would like this piece. And of course, I totally understand why, but I just think it's very, very cool. So yeah, he told me he was going to have this framed and mounted um, with his other pieces of artwork in his home, and so I'm thrilled. I think that's just um, very, very cool that somebody would consider this nice enough, to buy and to add to their collection. So because this is astronomical data, and I can write um, software to draw these things in any way. I can do things like have this is supposed to be sort of like a three-dimensional type of representation of this, almost the same thing. You can see that the colored ring isn't the outer um, ring anymore. So yeah, I don't know if that's interesting or not. I saw it there, so I decided, to post it up. Uh, let's see. Did I do anything else? I don't think I put anything else here. But anyway, that just reminded me when I was looking at the Parker Solar Probe. They have a fluxgate magnetometer. That reminded me of the same instrument on Juno, and the fact that um, uh, I had done some artwork. Hey there, Hip. Hope everything is well. Back in action, absolutely. Just yeah, yeah. Just sometimes life gets in the way and beat you to a pulp, so you're just a blob on the floor, a weeping blob on the floor, and that's pretty much what I was last night. But yeah, yeah, no problem, no problem. We are back. So what I wanted to do too was actually look a little bit harder at the Parker Solar Probe. Tony did a show on this the other day where he actually talked to a couple of the scientists who have an interest in and I think worked on either the design or the specification for some of the scientific instruments on there. But I'm I'm taking a look at this sort of in a different way, just sort of getting some basic info down and not necessarily focusing all that much on how close it's going to get, how fast it's going to move, um, you know whether the heat shield is going to survive or not. Let's just assume that all is, and how many times it flies by Venus and all that. It's like, well, that's all very, very cool, very interesting, amazing, amazing astro navigation, right? Just absolutely mind blowing what these poor people have to do to slow a spacecraft down enough to get it sort of a little tiny, tiny, tiny bit close to the sun, right? But the thing that I liked most was actually uh, was actually this link here. This is the Parker Solar Probe Science Gateway. Science Gateway. So this actually, it's time to nerd out, right? It's time to nerd out and take a look at this spacecraft a little more closely and just you know as I say, I just like looking at a lot of the pictures and stuff, and I see that they have a little slideshow here running that looks pretty cool. Is there a way I can zoom in? Hold on. Oh, not like that. Oh yeah, just like that, just like that. So let's do that. And we get the caption in here too. Uh, oh, now it's not feeding forward. All right. Well, I don't quite know why it's not feeding forward now. There it goes. What is that? I don't know. All right. Well, forget that. We'll just do it the old-fashioned way here. Looks like maybe a fuel tank of some sort. Electronics for sure. Very cool. Well, there's a bunch of instruments on this spacecraft. Um, solar wind electrons, alphas, and protons investigation. Um, okay, so they're just counting electrons, protons, and helium um, ions. You can measure, their different speeds, basically, and get an idea about what they're doing there and why they're there, and how fast they're moving. The solar probe cup, solar probe analyzers, wide field imager. So I guess I got the impression from the interview that Tony did, that there wasn't going to be any imaging systems on this. So I'm kind of curious now. Okay, take care, Hip. Glad you could stop in for a while. You can stop in anytime you want. For the most part, for the most part, we're here. I'm here. 2 hours UTC every single day. So step on in anytime you want. The is it this one? Yeah. So they're going to have a wide field imager. It'll make 3D images of the sun's corona. Experiment actually will see the solar wind and provide 3D images of shocks and other structures. That might be very interesting. I, I, are they going to be able to see structures? Wow, pretty nifty, pretty nifty. Um, and yeah, it sort of seems as though the imager is going to sort of be able to provide a context for all the other instrumentation. So it don't necessarily have to be completely blind um, when you're measuring um, the energy of one of the electrons. You can sort of say, okay, well, that electron was right there. So yeah, or coming from that direction. Um, okay, and then the electromagnetic fields investigation. Oh, excuse me. Um, it's going to make direct measurements of the shock waves that move through the solar wind. Hmm, okay. So 2 flux gates magnetometers, coil magnetometer, and 5 antennas measuring the electrical and magnetic fields. Cool. That is a well packed instrument. Wow, it's got a lot of stuff in it. And then there's ISIS, and that's the integrated science investigation of the sun, which consists of 2 instruments that'll take an, an inventory of elements in the sun's atmosphere using a mass spectrometer. Very cool. So yeah, I think the lady who was Tony's guest yesterday, was talking about how they're going to be able to sort of taste or sniff the atmosphere, and that's what a mass spectrometer does, right? It gobbles up all this stuff and sorts what it has by mass. And if you do that, you can get an idea about, what it is. So that's very, very cool. Uh, nice. So, so this also looks like it's going to be a data portal, because I'm reading here and it says, as part of the development of collaboration with the broader heliophysics community, the mission has drafted a rules of the road to govern how PSP instrument data is used. And the first number one thing is that the PI, the principal investigator, okay, shall make all scientific data products available to the public as stated in the PSP Science Data Management Plan. So yay, 3 cheers. We're going to have more data coming out our ears. That's just what we need, is more data. So, you know, um, unfortunately, it sort of sounds like, and this is info that I heard again on um, Tony Darnell's Deep Astronomy show from yesterday. Is that it looks like they're only going to be turning the instruments on um, at the various perihelions when it's closest. So we're not going to have a continuous uh, stream of data, for years and years and years. We're going to have, I don't, let's see, don't really even remember how many orbits is is in the primary mission. I know the primary mission is going to be going for like, well, yeah, it's like a 7-year thing. Um, so, but yeah, still a lot of data. You're just not going to have a continuous thing. You're only going to have data um, at closest approaches. So, and that's cool. That's cool. I look forward to seeing that kind of data. Hopefully, telemetry is also going to be involved in that. Telemetry is sort of the housekeeping stuff. Temperatures of instruments, and how much fuel is left, and all sort of the maintenance, housekeeping kinds of things too. There's interesting data in that as well. So let's see. Do we have anything else here? Anything else? Data. So of course there's no data yet. Planet. Oh, orbit plotter. Here we go. Obviously I didn't look at this closely enough. Let's see. All right. Well, we gotta play around a little bit here then. Fully available spacecraft ephemerides follow the following intervals. Okay, well, yeah, I don't know if, let's see, get PDF, get PNG, update. Let's see what update does. Update doesn't seem to be doing anything. That's probably not going to show us much, I guess, quite yet. All right, let's move on. Planning, science planning tool, payload. I gotta have to log in. What is this publicly available stuff here? Times planning tool project. Let's see if that's no, you gotta log in for that too. Oh, those creeps. All right, screw you. General, let's see. Bibliography, PSP meetings. All right, well, cool. I think that's about it. It's a pretty exciting mission. hopefully, we'll find some things. The probably the most interesting thing uh, to me is oh, it's kind of interesting. Some papers there is there is, and I thought I thought I included the links to that. There's a big long paper. Now this particular one, this is just about the ground-based support. But what I thought was interesting about this is that they get into the science objectives and look at all the questions that they have, right? How is the energy from the lower solar atmosphere transferred to and dissipated in the corona and solar wind? What processes shape the non-equilibrium velocity distributions observed throughout the heliosphere? It just goes on, just all these questions, right? How do the corona and inner heliosphere magnetically connect to the sun? Lots of questions, lots of questions. So there's just the instrumentation again. So, okay, yeah, science capabilities, offer full sun coverage for mission planning, scientific context, and mapping the origins of the plasma. So, yeah, at the same time, right, that this spacecraft is going to be zooming around the sun, we're going to be looking at the sun from here on Earth, right? Very cool. Oh, yeah, I'm not going to go through all this. You can read this for yourself. National Solar Observatory. Yeah, very cool. All right. There were a few other interesting papers that I saw over on archive.org that you may want to check out, including this ring galaxy. So uh, um, this is a galaxy that has been shaped by the collision of itself with another galaxy, and they've identified that other galaxy, and they're just looking at the results. They're looking at the hydrogen um, inside of NGC 922, and just sort of getting an idea as to what's going on after such a exciting event happens. And looking at the pictures, I mean, it's definitely a very, very, very odd shaped um, um, galaxy. Is it really in the shape of a ring? No. To me, it looks like a bubble. But you have to call these things something. So a ring galaxy is as good as yeah, good as anything else. So anyway, take a look at that one. Maybe I'll talk about it tomorrow night. Let's uh, let's do a quick object of the day. Huh? So let's go to random.org. We're going to choose from the NGC catalog tonight. That's the new general catalog. Random.org is a website that will, in an unbiased way, choose numbers for us. So there are 7,840 NGC objects. Now, most of these are what are called non-stellar objects. They're objects that aren't stars, right? So galaxies, um, open clusters, globular clusters, planetary nebulae, and gaseous nebulae. Now, it turns out that some NGC objects were misidentified and actually are stars. We came across one of those a couple of weeks ago, where it's that's a star. It's an NGC object that's a star. So that can happen. That can happen. But let's see what happens this time. So we're going to choose an integer. We're going to have random.org choose an integer between 1 and 7,840. Okay, drum roll, please. 7046. 7046. So let's go over to Simbad. And I did my homework on Simbad. I looked at those other um, tables that were always sort of, I wasn't quite sure what they were. I know what they are now. Yay. So maybe we'll see a few of those here and we can just look at them briefly. It's no big deal. So 7046, 7046, NGC 7046. Now, most likely this is a galaxy, but who knows? See, it's like a spiral galaxy. So here are the coordinates, the right ascension, 21 hours, 14 minutes, 56 seconds, and the declination, 2 hours, 50 minutes, 5 seconds. So let's see, that puts it very close to the celestial equator, right? Just a couple of degrees north of the celestial equator, and at 21 hours. So I'm trying to think about where that might be. That's is that mm, Pegasus is over there. I don't think it's Pegasus. I think it's yeah, it's a little west of Pegasus, but Uncle Bill, I'll bet you, will throw this up onto the Discord server, and then we will know exactly where it is. So let's see. It's so it's apparent size in the sky, 1.7 by 1.1 arc minutes. So it is, and as you can sort of see by the picture here, right? So this would be the 1.7 arc minutes, and this would be the 1.1 arc minutes. And it has a position angle of 165 degrees, which, well, if this is north and this is east, 165, huh? Yeah, I don't know about that. 165 would be like this. So I don't know how they're getting that number. But let's move on. We've got a B magnitude. So these are the magnitudes, the brightnesses of this galaxy, just looking through different filters. So, each filter has, okay, so it's right between I'm Aquilus, I'm an Aquarius. Cool. Thank you, Uncle Bill. So these are just filters, that have a certain central wavelength and then a band pass, and we just measure the brightness of this object, with different filters, and you sort of get a sense of things that way. So B is sort of visible blue, and then J, H, and K are more towards the infrared. So you can see um, in the astronomical magnitude scheme of things, right? The smaller the number, the brighter it is. So a 10th magnitude here is brighter than a 14th. So it seems to be pretty bright in the infrared, not so bright, that's pretty faint actually, um, in the visible. If you want to be able to see this object with your own eyes, you're going to need a pretty big scope. You need a pretty big scope. I'm talking 16-inch, 18-inch, 20-inch in order to see down to magnitude 14.2. That's very faint. The difference in magnitudes is a factor of 2.5. So the fact that this is, well, it's close to 3 magnitudes, right? So that's 2.5 times 2.5 times 2.5, or 2.5 to the third, right? So that's a factor of 15.6. So it's 15.6 times brighter in the infrared than it is in the visible, about 3 magnitudes. All right, let's keep moving down here. So there's all the different names of this object. 7046, of course, UGC 11708. It's got a bunch of other ones. Pretty typical. Few references, not too bad. We'll take a look at a few of those. Let's see, now this is showing how far away we think this galaxy is. What does it say? 55 and 58.8 million parsecs. That MPC, that's a million parsecs, or a megaparsec. A parsec is 3.26 light years. And a megaparsec is that just times 1 million. And then we got to multiply that. Let's see, let's go right in the middle. So what's that going to be? That's going to be about 56 and a half. So 56 and a half million parsecs, 56.5, gets us 184 million light years. So we've measured this in a couple of different ways and have determined that this galaxy is roughly 184 million light years away. So that's quite in our neighborhood. We're sort of, yeah, bumping elbows a little bit there. Look how consistent the measurements on radial velocity is, though, about 4,160 kilometers per second. It's moving away from us. So it is screaming away at 4,100 kilometers per second. Now I hear my Discord live chat going off like crazy, and yep, it's Uncle Bill zooming in on NGC 7046. Yay! So this just gives a nice context. Thank you, Uncle Bill. This is Stellarium, and it's free, and it's very awesome. I encourage you all to take a look at it. Yeah, a very awesome piece of software. And Uncle Bill here is kind enough to post some screen captures kind of showing where this object is in the sky. So thank you, Uncle Bill. That's very awesome. Appreciate the support for sure. I cannot tell you how awesome it is to have these kind of people on board. It's just awesome. Thank you. So moving away from us pretty fast. So, it's, if you remember from a couple of nights ago, we were looking at the radial velocity of Hydrus 1, right? And it was like 150 kilometers per second. basically moving with us, right? Basically not moving at all, especially relative to this. 4,100 kilometers per second. That is a screamer. And still relatively in the neighborhood, right? That's nothing. Let's see, it doesn't look like there's any observations here. Plots and images. All right, well, let's quickly look at the papers. Totally nerd out on the papers. Galaxy groups, a 2-mass catalog. Here's some more H1 data for the Cosmic Flows project. I don't know what the Cosmic Flows project is. Should we look at that really quick just to find out what the Cosmic Flows project is? These papers, and I'll say this every single time, these papers are awesome just as they are, right? Awesome just as they are, but they're also jumping off points, okay? I see something like the Cosmic Flows project, and it's like, what is that? Okay, what is that? Let's find out. Let's go over to ADS, and hopefully the paper will be available. Yay. I just want to know what the Cosmic Flows project is. Does it say here? Okay, yeah. Here it is. Cosmic Flows is an international multi-element project with the goal to map motions of galaxies in the local universe. Cool. Okay. I hear live chat beeping over here still. What's Uncle Bill up to now? Oh, okay. Yeah. Yeah. You could probably add one. I think, Stellarium, I think you can do that. You can add a skin or a texture uh, if you wish. I would think so. All right. Anyway, that's what the Cosmic Flows project is. All right. So let's go back. One more. From Spitzer Galaxy photometry to Tully-Fisher distances. 2-mass redshift survey. There's another Cosmic Flows. So Cosmic Flows was talked about in 2015 and 2011. So Cosmic Flows has been going for quite a while. Extragalactic Distance Database. All digital H1 profile catalog. Cool. I bet you that took a lot of work. All these papers do. There's just an insane amount of work here. And we just scan over them as if they're just like nothing at all. But people, these authors have put some blood, sweat, and tears into this work. And we just scan it. Oh, that doesn't sound interesting enough to look at. Mass to light ratios from the fundamental plane of spiral galaxy disks. Nearby optical galaxies. ESCZ catalog. Updated Zwicky catalog. Cool. Total magnitude, radius, color indices, color gradients, and photometric type of galaxies. Very cool. All right, let's take a look at the picture really quick. Gotta take a look at the picture. Come on. Always zoomed in like hugely. It's a nice, pretty spiral. I didn't see, I didn't look at this at the galaxy type. Let's go back and take a look at that. Okay, so they're calling it an SB, as in boy. So S, of course, stands for spiral, and then there are different um, sort of tightnesses or compactnesses of the spiral arms. So an SB, well, an S0, right? An S0 is a spiral galaxy that you can barely see any kind of spiral structure at all. It's not a lot of gas and dust. There's not a lot of structure. And then it goes SA, SB, SC. Um, yeah, there might be other morphologies there, but SB is just sort of your average spiral type. I'm sort of thinking that the Milky Way is an SB. I, I I guess we think that it's some kind of barred galaxy now too, but it's sort of an SB type, so sort of like that one. All right, now let's look at the pictures. I like to zoom out a little bit just to give us maybe a little bit of context, see if there's anything else around. Looks like there's a couple other little galaxies here. This one, little little fuzzies. Yeah, there's quite a few fuzzies. I would think that all of these galaxies would be in the background of NGC 7046. But all these stars, of course, all these stars, everything in this that isn't a galaxy is most likely a star, and every single one of those stars is in our galaxy. So, how many stars are just in this field of view alone? It's just mind blowing. Oh, so here's another galaxy over here. Very cool. Let's take a look and see what it looks like. A spiral also. Don't know which one it is. Oh, no, maybe not. Maybe it's an elliptical. Maybe it's an S0. As I was saying, it's kind of hard to tell. I don't really see any spiral arms there. So, yeah, hard to tell exactly what type that is. It's not up to me to decide those kinds of things anyway. But let's go back to 7046, and we can sort of zoom in here a little bit. Yeah, so there's some fuzzies around there. But again, this is a very faint galaxy. Now, if you were to look at this galaxy with your own eyes through a telescope, okay, um, what you would more or less see is just this central area here. Maybe you'd see a little bit of a fuzziness out here. But through a telescope, just plopping your eye uh, onto an eyepiece through what would have to be a relatively large scope, you're not going to see this. This is the result of a long exposure photograph, right? This might, this is probably at least several minutes long. It's kind of interesting, the structure here. You see how this has got this one arm that sort of extends out this way, and it's not happening on the other side. So it's got some interesting structure to it. Very cool. Very cool. All right. Well, I think that's going to wrap it up for tonight. I'm so glad that you all came by, sit around for a while, and chit chat about all things astronomy. So the cool thing about having this daily live stream is that it's very casual, it's very relaxed. Um, we can dive in as deep as we want. We can go really shallow, whatever. And so far, my experience has been that tomorrow has come, and so uh, I I will say that I will be back, but I will not be back tomorrow. Okay, tomorrow is the gig day, and so I'm going to be playing out at at a musical event, and that'll be a lot of fun. Um, and so this live stream will not be happening tomorrow, but it will be happening the next day. So April 23rd at 2 hours UTC, I will be back right here, plopping right down in this chair, and uh, I'll probably tell you a little bit about the my experience at the festival. This will be the first time that I've ever played at a festival. I've played out um, a few times, but this is sort of a different thing. This is going to be a center stage, and there's going to be hopefully quite a crowd. So the cool thing is that we are playing at sunset. Okay, so it's like uh, couldn't couldn't be any better. Couldn't be any better. We're going to be playing at sunset, and it's going to be very, very cool. It's going to be very, very cool. So I am looking forward to that. I'm also looking forward to getting back here on the 23rd at 2 hours UTC. So if you're just stumbling across this channel now, make sure to subscribe. You can hit notifications to be notified as to when I do go live, but it is at 2 hours UTC. I want to say every single day, but that's an impossible uh, target. But I think I've been doing this for a little over 3 months, and I have missed two. I've missed two. Tomorrow will be three. So in 3 months, 3.5 months, something like that, all have missed three. So you can sort of get an idea as to the extent and excitement of my life. No, this is about as exciting as my life gets, and that's exactly what I want. It's exactly what I want. Sitting here talking astronomy with friends. Hey, I don't know. There's not much that could be much better than that. So, all right. Yeah, I'm getting the call from the mothership. Gotta get up. Gotta get up. Have a great evening. Have a great day. So glad that you could stop by again. Stop by any time. Anytime. Don't feel as though you have to come in here every single day. If you do, far out. Far out. But don't think that you have to. Come in whenever you want. Okay? Every other day, every week, every month, every year, whatever it is. And whether you're new or some kind of an amateur or a pro, you're welcome here. You're extremely, extremely welcome here. Um, I'd like to get a nice sizable crowd in here to have an interesting conversation, interesting topics, whatever. Still aiming for that goal. We'll get there. We'll get there. All right. I'm going to get out of here for now. Peace, cheers, and all that. Take care, and I will see you two spins. Two spins from now. Don't get dizzy. All right. See you later. Bye.